Okay, so we're going to go through section 7.1, okay, and it's solving exponential functions. And so let's start like this. What if I had 2 cubed? Same thing as 8, right? What if I had 2 cubed is equal to 2 to the x? Could we solve that? Well, really, since the bases are the same, you can just cross them off and you have x equals 3. Now, that only works if the bases are the same. But what happens if I had 2 cubed is equal to 8 to the x? Okay, so these bases are not the same. But can we write this so the bases are the same? Okay, and this is the key to solving all the problems in this section. Okay, so 2 cubed stays the same. Is 8, can I write 8, which is 2 cubed, right? Can I replace this with this? Okay, and the answer is yes. So that'd be 2 cubed to the x. Okay, so now when you have exponents like this, okay, so when you have an exponential raised to another power, you rewrite that and say 2 cubed is equal to 2 to the 3x. And see how the bases are the same now? You can cross them off. So now I have 3 is equal to 3x, and I have x equals 1. Okay. So the key to solving exponential equations where there's x up here is to get the bases the same. Okay. So you might make a chart where it's 2 to the first is equal to 2, 2 squared is equal to 4, 2 cubed is equal to 8, okay, 2 to the fourth is equal to 16, so on. And then 32 is 2 to the fifth, 2 to the sixth is 64, so on. And do the same thing with 3, same thing with 4, same thing with 5, okay, because you'll find that you use those quite often, okay. So let's go through a couple of examples without erasing that. Okay, so the first one is 4 to the x minus 4 is equal to 32 to the negative x plus 2. Okay, so see how the bases are not the same. Okay, but what you want to do is write it with a simple base. Okay, so like see how 4 is here and 32 is here? So I'm going to replace the 4 with 2 squared, x minus 4, and 32 with 2 to the fifth, negative x plus 2. And since I have the same base, I can just cross them off. Okay, so now I'm 2x minus 8, I distributed, is equal to negative 5x plus 10. Move that over, so it's 7x minus 8 is equal to 10. Add that over, 7x is equal to 18, and x is equal to 18 sevenths. Okay, so get your bases the same, and it's pretty easy to solve. Okay, let's see the next one. The next one is 2/3 to the 5x plus 1 is equal to 4/9 to the 6th. Okay. Notice that these are primes. Okay, so those don't have any bases. But can we get each one of these numbers out? Okay, so where it looks like 2/3. Well, notice that if I squared 2, I get 4, and if I squared 3, I get 9. So really, I can rewrite this side as 5x plus 1 is equal to 2/3 squared, which would be 4/9 to the 6th. Okay, bases are the same now, so I can rewrite it and say 5x plus 1 is equal to 12, 2 times 6. Then subtract off 1, 5x is equal to 11, and divide by 5x is equal to 11/5. Okay, so all of it is about making sure you can get the bases to be the same. Okay, so 3 to the 3x minus 9 is equal to 1/9. Okay, so anytime you see a fraction, such as 1/9, realize that when I go 3 to the negative 1 power, this is the same thing as saying 1/3. It just flips it. Okay, 3 to the negative 2 power is the same thing as 1 over 3 squared, which is equal to 1/9. Okay, so this is how you get fractions with the negative. Okay, so if it was like 1 over 27, this is the same thing as 3 to the negative 3 power. Okay, so 1/9. 3 to the 3x minus 9 is equal to 3 to the negative second power. Bases are the same. Cross them off. I'm left with 3x minus 9 is equal to negative 2. 3x is equal to 7 as I add 9. And the x is equal to 7/3. The next one. 10,000 to the negative x is equal to 10 to the x minus 6. Okay, so 10,000. Let's do the tens. You would think it would be a base of 10. So 10 to the first is equal to 10, which is where I get that. 10 squared, 100. 10 cubed, 1,000. 10 to the fourth, 10,000. Okay, so notice I'm going to replace 10,000 with 10 to the fourth. Minus 6. Bases cross off. So I'm left with negative 4x is equal to x minus 6. Let's subtract that off. So negative 5x is equal to negative 6, and divide by negative 5x is equal to 6 fifths. Okay. So the next section that you got to do is just graph it. How would I graph it? Well, let's do a chart. Let's go to, let's say I wanted to graph 2 to the x. Okay. Now, when they do these, all of them are going to be multiple choice. So you just got to pick one. Okay. So if you can get the basics of the graph, that's pretty much all you need to do. Okay. So if I had to graph 2 to the x, okay, I'm going to make a table. Okay. Now, do you need to do this? No. And so if this is what x is equal to, we'll start with 0, 1, 2, 3, 4, 5, 6, so on. Okay, now we don't need to fill out the entire thing, but realize 2 to the 0 power, okay, so anything to the 0 power is 1. Okay, so almost all of these graphs, if it's not a +3 or +5 or something like that at the end, they all go through the point 0, 1. Okay. So this is the main point that you need to look for. And notice anything less than 0, so like -1, that would be same thing as 2 to the -1, which is equal to 1/2, 1 over 2 to the first. 2 to the -2 would be 1 over 2 squared, which would be 1 over 4. And notice I would never get anything less than 0. So I'm going to get closer and closer without ever hitting it. And then 2 to the first is 2. So and 2 squared would be 4. So 3, 4, somewhere up there. Okay, so notice the graph is going to come hit and come up. Something like that. So almost all the graphs will look like this. What happens if it would be negative here? So what if I had the graph of 2 to the negative x? Okay. Well, instead of this being 2 and this being 4, this would be 2 to the negative x. The same thing, it would still be at 0, you'd still get 1. Let's see, at 1, you'd actually get 1, 2, 3. At 1, you'd be 2 to the negative first, which is 1/2. We had that there. 2 would be 1/4. Okay, but at 0, it's still 1. So this point still exists, except now, see how we just flipped this graph? So now it technically looks like this. Okay, so notice, if it's negative, it's going down. If it's positive, it's going up. That'll help you when you start talking about multiple choice problems. Okay, so when the question arises and we have q of x is equal to 4/5 to the negative x, Okay, and we have to graph this, or we have to pick a graph. Okay, so the first one goes through 0, 1, and goes down like this. That's A. B goes through 0, 1. It goes up. C goes through the point 0, 2 and goes up. And D goes through the point 0, 2 and also goes up. Okay. So notice there's nothing up here. Okay, so nothing there's nothing out here that says +1 or +2 or +3 that would move the graph up or down. And there's nothing in here that would move it left or right. Okay, so you need to understand that anytime it's just x or negative x, the point 0, 1 has to be in your graph. Okay, which means this one's out and this one's out. Okay, these two are the only ones that are left, A and B. Now, since it's negative, it needs to be going down. Okay, and you could tell that by if I just plug in a number like 1, -1, so that would just become 5/4. Let's check that out. Am I right? Okay, which one could it be? Well, let's plug in 1. Let's plug in 1 here. Now, remember, this is the point 0, 1. So let's look. 4/5 to the -1. What's that going to do? Well, that should flip this, because that would be 4 to the -1, which puts it on the bottom. And then 5 to the -1, which puts it on the top. So this would be, your answer would be 5/4. So is it going to be bigger than 1 or less than 1? Okay. Well, this one's bigger than 1. Okay, so really, see how this was negative, but it was already a fraction. That's why it flipped it from going down to going up. Okay, so your answer will be B. Okay, so that's how I'd answer multiple choice questions. Look to see, is the point 0, 1 there, if it's just x. And then really just plug in a couple points and you should be okay. All right, let's do one more. So this one says P of x 5/2, which is greater than 1, to the x minus 3. Okay, so here's the graph, looks like this. It's clear down there. There's the point 0, 1, so it doesn't hit there. But it does hit at -3, 1. B. Let's see. Looks like this. And the point that 2, 1. I would always try to look for where the point 1 is. So -3, 1, or the y value of 1. C. Goes this way. It hits at the point 1, 2, 3, 1. And D, clear up here at 4. 2, 4. Something like that. Okay, so what you could do is just plug in points. Okay, and so what I would do first is plug in 0. Okay, or figure out where it's 1. Now, what does the -3 do to the graph? Okay, and I think we've talked about this before. Okay, the -3 as it's in here, if it's not -3 clear out here, the -3 that's involved with the x should move it right 3. Okay, so your original point is a 1, 0, 1, but it's not because we moved it right 3, so it'd be 3, 1. Okay, now there's only one of them that has the point 3, 1, and that's your answer. Okay, and you could have got other points by, like, let's say we plugged in 3. So we would have 5/2, 3 minus 3. So that'd be 5/2. It'd be 5/2 to the 0, which is 1. So at the point 3 is 1. And this is the only graph that has that. So you could have plugged in points, got the right answer without even thinking, oh, I have to move it right 3. You could have just plugged in points and got the answer. Okay, so whatever you want to do on that one. So that's 7.1. Let me know if you have any questions.